Okay, if there are no more questions, and again, I encourage you to email us if you have any, we're going to start part 2. I'm going to introduce David Visner to present information on the Google Cloud Platform and BigQuery. Dave is a systems engineer at Technome and is managing data operations for AMPD. He's been working with the NIH on a number of collaborative multi-study bioinformatics data sharing projects, including our PDBP project. So I'll turn it over to Dave. Thank you.
Thank you, Deb. As Deb mentioned, I'll be introducing the Google Cloud Platform. The AMPD system is built on top of the Google Cloud Platform, which provides both hosting capabilities for our data and the ability for users to interact, for researchers to interact with the data and do processing. The traditional method of hosting data on a project like this is to have a large data repository centrally located and to have researchers then access the data from there, download it to their own machines, and use their own tools to process the data. AMPD and the Google Cloud Platform are presenting a different methodology, which is to have the tools and the data available in the cloud, and the researchers will just log into cloud machines and do the processing directly there. So some of the issues with the centrally located data but remote processing are security concerns with the data located in a number of different places rather than just centrally located. There's a considerable cost and slow speed when transferring data out of the cloud, particularly for large genomics data. And having the tools located with the researchers and not centrally located discourages shared research. So what we're trying to do with the AMPD platform is to encourage shared resources and shared research by having all of the tools centrally located where they can be shared among researchers. This also provides the additional capability of just paying for resources when you need them. So because the Google Cloud Platform is scalable, you don't have to pay for a large infrastructure and a large amount of processing capability that you only need sometimes. So now I'll give an overview of the Google Cloud components that are primarily used. The first of those is Google Cloud Storage. Google Cloud Storage is like a large shared drive that can be accessed by all the researchers who are accessing our data, and can also be used by researchers to host their own data. It provides a unified file storage capability, and it provides a number of interfaces, including web-based interfaces and APIs and command line tools. The second component is the Google BigQuery database. The BigQuery database is similar to, for people who aren't familiar with databases, they're like a set of large spreadsheets that are stored in the cloud. You can run queries against them to get only particular columns of data, particular rows of data, only data that meets certain criteria, and we refer to that as querying the database, and I'll go over that in more detail. And the final component that I wanted to talk about before we begin the overview is the Google Cloud Compute Engine. The Compute Engine allows you to create virtual machines on demand, so that when you want to do some processing, you can create a virtual machine of whatever capability you need, do the processing, and then you can shut that machine down, so you don't have to have a set of machines that are available at all times. So now I'll go a little deeper into Google Cloud Storage. So Google Cloud Storage is a high availability, high performance, scalable solution for data storage. As I mentioned earlier, it works similarly to a hard drive or an FTP site. you can upload data to it, download data from it, and you can browse the data that's stored in the cloud. There are a number of different methods of accessing that data. There is the Google Cloud Platform user interface, which I'll show you shortly. There are command line tools that are available if you want to run it from either a local machine or a virtual machine. And there are APIs to allow you to build applications which have access to the data on the cloud. So now I'm going to give a brief demonstration of the cloud storage capabilities. So first I wanted to show the AMP-PD data that we have in the cloud that's available. We have it split, as we mentioned, it's split into two different tiers of data. There is the clinical data, which is available to any approved user, and then we have tier 2 data, which contains genomic data. So the clinical data is in our AMP-PD data folder. And right now we just have our first release in here, but when we do additional releases, they'll be included as well. So you'll have the ability of getting to the newest data or previous versions of the data if you had research that was already doing that. So within the cloud storage, you can browse it just like you would on your hard drive. You can go down through folders, get straight to the what I'm showing now are the clinical data files in CSV format. So those can be downloaded directly from here. You can also create buckets in your own project. So this is a demonstration project that we've created for this demo. And in this project, I've created a sample data bucket. And there's nothing in it right now, but we can upload data to it, use this, we can access this from applications. I also want to show a virtual machine. So if you create a virtual machine and you want to use the data and process it from there, you can use the GSUtil command, which is part of the Google Cloud Platform. It's a set of command line tools. And I have a few commands that I want to show. So the GSUtil command provides a number of functionalities that you can use for accessing cloud storage. It has a list command, ls. It has a copy command, cp. These are similar to Unix commands, if you're familiar with that. So the first one I'll show is the GSUtil ls. So I'm listing the contents of the clinical data folder that I just showed you in the Cloud Platform user interface. So this works similarly to an ls command. There are additional options available for listing file sizes, dates, things like that. We can also do a copy command. So what I'll show you now is copying from our clinical data into your own cloud storage bucket. So this will put the clinical data that we just looked at into our own storage bucket so that we can access it from there. And so what's happening is a bunch of individual move commands, and it's going through, it's taking all of those files and moving them individually from the AMP-PD data storage into your own cloud bucket where you can change the data, access it, manipulate it in whatever way you want. So as you can see, it's fairly slow when it has to do move individually through the files. There is also an option, an important option with the gsutil command, which is the multi-threading option. If you add the -m to it, it will move a lot faster because it's doing multiple jobs at once. So that's fairly important once you get to exceptionally large file sizes. So there is also the listing command on the, so this is showing what's now in our storage bucket. And then I'll just show you the remove command, which we can use to get rid of all of that so we can have a fresh, clean bucket again. And this again is going through and removing all of the files. So now I'll go back into our presentation. And we'll talk a little bit about the BigQuery functionality of the Google Cloud Platform. So the Google BigQuery is a fast, scalable, and automatically optimized database hosted within the cloud platform. It provides support for standard SQL querying, as well as a number of other functions and the ability to do processing directly within the BigQuery platform itself. It's particularly well optimized for querying massive petabyte scale data like we're providing with AMP-PD. Now I'll take a little time to give you a demonstration of the BigQuery capabilities of the Google Cloud Platform, and I'll show you our data in it. So when you're in the Google Cloud Platform user interface, you can move around through the various components of the system with this navigation bar. Going into BigQuery. So all of the data sets that you have access to will be listed on the left-hand side here. The basic unit of storage within the BigQuery database is the data set. We have, again, as I mentioned, we have 4 of them in our AMP-PD platform. We have our Tier 1 clinical data. We have our Tier 2 clinical data with mutation information. And then we have our genomics data and our transcriptomics data. Within each of these data sets, you can open it up and you can see all of the tables that are in there. And again, you can think of each of these tables as being one spreadsheet. And you can open it up, see the data that's in it. You can export it to your local machine or process it within the cloud. As I mentioned, we have mutation information and clinically reported genetic status information. We have queryable variant information, and that's all available with an institutional signature to get Tier 2 data. So now I'll open up a saved query and show you how that works. So what I'm doing here, what this query is going to do, this is a scenario where somebody's interested in hand dexterity and how it relates to how it relates to Parkinson's disease in a particular cohort. They're interested in white males over 45 as the particular subjects they're interested in for this one. We're looking for specifically information from the MDS UPDRS form, which contains data on hand dexterity. So we're going to select that information for only participants who meet our inclusion criteria. And we only want subjects who have whole genome sequence samples available in our data, which is this part down here. When we run this, it gives us the results of our query, and we can browse through the results here in the user interface, or we can save the results out to our local machine or to a VM. And as I mentioned, there are command line tools available for all of these Google Cloud functions. And I'll show you an example of querying a BigQuery database from the command line. So in the same way that there is the gsutil command available for Google Cloud Storage, there is the BQ command available for BigQueries. It lets you create tables, delete tables, do various things to them, and it also allows you to run queries directly from the command line. So here I'm running a BQ query command. I'm telling it I want to provide a SQL statement. I only want 10,000 rows, and I want it to be in CSV format. And then I give it the specific query just like I created in our user interface. And when I run it, it doesn't work because I didn't copy it correctly. So let me do that again. So I'm not sure why this isn't working. But you can run queries directly from here. I won't go through and debug this right now. But it will print out the CSV file directly into the standard output, where you can pipe it into other applications and processing if you want to. I'll go back to the presentation. And we'll talk a little bit about the Google Compute Engine. So the Google Compute Engine provides infrastructure as a service, and it allows you to pay only for what you need. So rather than purchasing a number of computers or purchasing physical machines or space on physical machines for your virtual servers, you can create them within the Google Compute or Google Cloud platform. You can create as many of them as you want. You only have to pay for them as long as you're using them. You can do your work, and then you can either pause them so there's limited costs, or you can get rid of them entirely so there are no costs associated with them. The Google Compute engines are designed to withstand multiple data center outages, so you don't have to worry about your machines being unavailable if the data center goes down. They're hosted all throughout the US and through the world. And the additional feature of the Google Cloud engine, the compute engines, is the ability to work with the the AMP-PD data within the cloud so that you don't have to download potentially petabytes of original data down to your local machine. The compute engine can work with AMP-PD's data in the cloud. It can access it from there, process it, and then you only have to store the output data from your processing. I'll now give a short demonstration of the compute engine. Within the cloud platform, if you go to the compute engine section, this allows you to create new compute engines. It allows you to access and control the ones that you've already created. And you can pause, as I mentioned, you can pause them and you can get rid of them. So, to create a new one, you would click on Create Instance. And then there are a number of options in here. You can choose the number of CPUs that you want it to have, the amount of memory you want it to have. You can choose the size of hard drive you want, where it's hosted. There are a number of different options that you can choose for that allow you to save money on it or get the processing capabilities that you need. So once you've configured it, you would just say Create, and then it would show up here in your list of virtual machines. So this is the one that we've been using for our demo. To launch it, to open it, you can either use a command line to open to SSH into it, or you can open an SSH session to it from the cloud platform user interface here. So, as I said, this is the virtual machine that we've been working on. An important thing to note: when you create a virtual machine, it doesn't automatically have your user information. So once you create a virtual machine, if you try to then use our gsutil commands or access the AMP-PD data, it won't be able to do that. It won't know who you are to do that. So what you have to do is use the gcloud auth login function, and that lets you do a Google login. It gives you a URL. It asks you to this is in the way. So it lets you put that URL in. You would then select the user you want to use. Tell it you want to allow it to have the access you need. And then it will give you a string of data that you can then copy and put back into your machine. And now you're logged in. And this will stay alive over multiple sessions. So now when you try to access the AMP-PD resources, it knows who you are and it can authenticate you. So those are the major three cloud platform components that we wanted to discuss. There are a number of other features in the Google Cloud Platform. There is identity and access management, which allows you, if you're a research program, it allows you to create individual user accounts and to give permissions to various users rather than just allowing them access to everything within your project. There are logging, monitoring, and auditing functions to it, which allow you to see what people are doing, who's accessing the data, what processing is being done, things like that. There's also billing and cost tracking, which we'll get into in more detail later. And there is deployment and scheduling, so you can have things happen on an automated basis. And there's artificial intelligence and natural language processing capabilities if you need those. So as I mentioned, There are billable activities, and things do get, it does cost money to use the Google Cloud Platform. Of the features that we talked about, there is a cost associated with storing data in the cloud storage buckets. There are nearline and cold line storage options available, which cost money to access the data, but cost less money to store the data. So on AmpPD, we use a number of different styles of storage to minimize the costs. BigQuery does have a cost associated with storing the data and with accessing it. It does cost to export the data and to query results, though it is a minimal cost. Also, compute engine usage, there is a cost associated with starting a VM and hosting it. And there's scaled costs as you use the virtual machine. And there is cost for the disk space that's used. As I mentioned earlier, if you pause the VM, that will eliminate any costs except the disk storage. And if you get rid of the VM entirely, your costs go away. There are options for tracking and managing costs within the Google Cloud Platform. It gives monthly summary statements. It provides a user interface that lets you do a lot of tracking, which we'll show later in more detail. And as I mentioned earlier, there is a requester pays option, which allows you to host data, and then if somebody else comes in to use your data, they would have to pay for the exporting the data, querying the data, things like that. I'll give a quick demo of where the billing information is in the Google Cloud Platform, and later we'll be talking in more detail about this. So again, this is another component of the Google Cloud Platform. You just navigate to it, and then there are a number of interfaces, a number of reporting capabilities, and options you can do for alerts. So go back to the demonstration now. And that's the end of the overview of the Google Cloud Platform. I want to take a few minutes if anybody has questions about the Google Cloud Platform.
Yeah, we have one question that is asking if the Google Cloud Platform is the only method that can be used to download data.
So you have to use the Google Cloud Platform to access the data, either the Google Cloud Platform or the Terra platform, which is a part of it. You have to use it to get the data, but you don't necessarily have to work with the data in the cloud platform.